height of the water or the depth of the water at any time during a 24-hour period at the Bay of Fundy, which is located in Nova Scotia, and it's got the highest tides in the world. Okay, so we want to end up modeling. We want to come up with an equation for this. All right, so the first thing we're going to do is find what the midline is. So our midline is the same as our vertical shift. That's going to be highest and plus the lowest. So our highest the water is 45 feet. This is 4 hours after it was measured, it was 45. And then 10 hours after it was measured, it was 6 feet. So 51 divided by 2, which is 25. Okay, so that's going to be my D value down here. 25.5, and then I'm going to graph that on GeoGebra link. Down below is just a normal sine curve. And I'm going to put in what D is plus 25.5. Okay, and then if I click on the midline here, that should correspond to where the graph is. Now my high and my low values will be a line at 45 and a line at 6. Now what we're going to do is get the amplitude so that these hills and valleys touch these red lines. So to get our amplitude, the amplitude A is the highest minus the lowest. 19.5. So we'll enter that. Okay, now we want to get the B value so that it has the same period as this. Okay, so our period is a little over 12 hours. Right, so we're going to substitute the period in the formula. P equals 2 pi over B, and solve the resulting equation. So the reason we got the period to be 12 hours is because earlier, looking at this, for each sine, you get 2 sine curves. There's one sine curve. There's just about a whole second sine curve and a 24-hour period. Okay, so if 2 sine curves fit 24 hours, then 1 sine curve is 12 hours. We have 2 highs, 2 high tides, and 2 low tides. Okay, so our period is going to be 12. 12 equals 2 pi by B. Now I'm going to solve that for B. 12B equals 2 pi. Now divide both sides by reduce that to lowest terms, get pi over 6. So that's my value of all right, so that's going to be pi over 6. Here in the formula, I'm going to put pi over 6. Put that in on GeoGebra app. So for pi over 6, I'm going to convert it to a decimal. If you got questions, guys, let me know. Pi over 6. Do that to a 3 decimal places. 5 to 0.524. All right, the last point to get is the phase shift. So we take the period and divide it into 4 parts. So we know our period is 12 hours. 12 divided by 3. So a normal sine curve would have its first max at 3, then 6, then the minimum would be at 9, and then that regular at 12. So its first max is at 3. That's this graph over here. This graph hasn't been shifted yet. Shift. So what this is telling us here is that this max is at 3. That's 345. Then this one here, or excuse me, this one is 6. It's at the midline. That's 6 hours in. It's 25.5. Then 9 hours in. It's 0.96. And then 12 hours in. Back to 0.12, 25. Now all we want to do is if we take these coordinates, okay, we want to match them to these coordinates. So this one is 4, 5. Halfway between 4 and 10 is 7. So that's 7, 25. This is 10, 6. 4, 7, 10. And that's the point. 13. So we want to take these coordinates and convert them into these. So you can see that if I just add 1 to the x coordinate, I'm going to get these new coordinates here. And so 3 plus 1, 4. 6 plus 1 makes it 7. Plus 1 makes it 10. 12 plus 1 is 13. So I want to move this graph 1 hour. 1 hour to the point. And so my phase shift is 1 hour. So C is 1. Type that in, it'll match up perfectly. So there's your model that calculates the height of the water over a 24-hour period in this particular